Hello and welcome. I'm Edwin. I'm a developer on the Cloud Solutions team here at Terraform. In this tutorial video, we'll go through everything step by step so you can get a copy of Terraform's cloud access software deployment running in your cloud environment. In this repository, you can choose to deploy in either AWS or GCP. This video will be demonstrating a GCP single connector deployment. Please check out our other videos for other types of deployments. Throughout the video, we'll be following along closely with our documentation to help flesh out some of the finer details to make your deployment as easy as possible. This way, the next time that you need a refresher to use these scripts, you can simply skip to certain sections of the README file as reference. So, let's get started. We'll first need to open up a browser and visit the GitHub repository page for our cloud deployment scripts. I already have a tab opened. We can be found on github.com/teradici/cloud_deployment_scripts. On this page, you will find a short introduction to our deployment scripts, and just below it, you will also find links to our documentation for both AWS and GCP deployments. We'll go ahead and open this up in a separate tab, so that way we can refer back to it as we move along. On the GCP README page, we'll find a short introduction here as well. And here it will mention two available deployment types. One is a quick start, and the second is running Terraform scripts. These deployment scripts were meant to be used with the command line interface and Terraform. In this video, we'll be using the second method. For a tutorial on quick start, please check out our quick start video. We'll be using the GCP Cloud Shell to make our Terraform deployment, so that way it doesn't matter if you're on Linux or a Windows machine. Under the Getting Started section, we have a list of requirements that we do need to satisfy before we can begin our deployment. We'll go through these together and make sure they're all complete before moving on. So before we dive into the setup section, I do want to go over the architecture section, which will contain more details on our deployments. The three types of deployments are single connector, multi-region, and a DC-only deployment. The DC-only deployment is intended for testing domain controller operations. The deployment we'll be covering today will be the single connector deployment, as this is the simplest one. These Terraform scripts will deploy all the VMs, which include the remote workstations, the domain controller, as well as the cloud access connector. This deployment creates a VPC with 3 subnets, which are shown in these yellow boxes. There are 3 subnets. The first one here is the subnet CAC, which is where the cloud access connector goes. This acts as the endpoint where clients connect and acts as a gateway to the workstations. The second subnet is subnet DC, which is where we'll create a Windows VM to serve as a domain controller that runs Active Directory. Remote workstations will join the domain here. The third subnet is subnet WS, which is where the workstations will be created, and they're isolated from the public internet. Firewalls are also created to allow wide open access within the VPC, and the selected ports are open to the public for operation and for debugging purposes. 2 domain admin accounts are set up in the new domain. These are the administrator and CAM admin. CAM admin will be the default account that we'll be using in Cloud Access Manager. Domain users are created if a domain users list CSV file is specified. We'll be covering this later on in this video. For more information and details on the architecture, please refer to this section in the README file. Alright, so under the Getting Started section, we do have a list of requirements we have to meet before we can make our deployment. The first item is that the user must have owner permissions to a GCP project. This is required so we can create a service account with the appropriate permissions to make all the infrastructure deployments. Second item is a PCoIP registration code. If you don't have one, please contact Terraform Sales, and we also have a link here for you to get in touch with us. Third item is a Cloud Access Manager deployment service account. So we will be going through this together under the Cloud Access Manager Setup section. The fourth item is a SSH private public key pair. So if you're not familiar with the SSH or creating keys, we do have a SSH Key Pair Setup instructions here as well. And I've got a tab actually of that opened. So it's got instructions on setting this up on a local Windows machine, as well as creating a key on the Linux machine. And this is the one that we'll actually follow today, as we will be using the GCP Cloud Shell to make our deployment. So we'll be creating our key using this. So we'll come back to this. The fifth item here is SSL keys and certificate files are needed in PM format. So it is optional, and for the sake of this demonstration and simplicity, we will not be using SSL, so we can omit this. The last item is Terraform, as this is what we're using to make our deployment. This is installed by default on the GCP Cloud Shell. However, if you are thinking of doing this on a local machine, you will need to have at least version 0.12 downloaded, and we've also provided a link for you here. The first thing we'll set up is our GCP environment. In a new browser tab, we can head over to cloud.google.com and sign into our GCP account. Once we're logged in, we can click on the console in the top right corner. And this will take us to the console page. Now, while it is possible to create deployments in existing projects, we do highly recommend creating them in new projects to reduce name collisions and possible interference with existing resources. I already have a project set up with no other resources deployed, so I will simply be reusing it. To create a new project instead, click on the project button up here, and we can enter new project. Provide it with a unique name such as Cloud Deployment Scripts Demo. Fill in the required fields and hit create. With the new project created, under the navigation menu in the top left corner, we can scroll down to IAM and Admin and select Service Accounts. This is where we can create a new service account to be used for this project's deployment. We can go ahead and click on the Create Service Account button up top. And to create a service account, we'll need to give it a name. We'll be calling ours Cloud Deployment Scripts. To continue, we'll hit Create. In this next step, we'll be adding the required permissions which are needed for Terraform to create resources and Cloud Access Manager to create new workstations with power management. The two roles we'll need to use will be the editor and the Cloud KMS encryptor and decryptor roles. In the future, we'll be updating our documentation here with a set of more granular least privilege permissions for each of the deployment types for better IAM security. Let's go ahead and add these roles. Go back to our GCP tab. First one will be the editor role. We'll scroll down a little bit to find it. We'll add a second role here. And we'll make sure we need both the encryptor and the decryptor roles. And we can click on Continue. Finally, we'll need to create a key for this deployment service account for Terraform to use later. We'll finish off by hitting Done. And just on the right here under Actions, we can go ahead and click on Create Key, and be sure to do this for the service account we've just created. And we will save this file as a JSON file. And we'll click Save, which will save to the local machine. We'll finish this section off with the next step, which is enabling the required APIs. If we head back over to our README file, we'll see a list of APIs that we'll need to enable. We've provided as well a command that we can use to do this in one step. So we'll go ahead and copy this command. We'll be using the Google Cloud Shell, so we'll head back over to the GCP console. In the top right corner, there's a button that says Activate Cloud Shell. So let's click on that. We can make our console screen a little bit larger by simply dragging this up. Now, the first time that the Cloud Shell is initialized, you may see the message that you have to set the project. So please double check that the project that you're on matches with the one that you've just created. And we can double check the name by opening up this screen and checking the ID column. If it doesn't match, we can simply use the command that's provided here, which is gcloud config set project, and type in your project name here. We're now ready to paste in the command. And we'll click enter. This may take up to 2 minutes, so we'll have to wait for it to finish. So after a couple minutes, you should see that the operation has finished successfully. So once you see this message, we're good to go. And this last item here has to do with the KMS encryption. As part of our deployment scripts, there is a KMS encrypted option. And once again, for the simplicity of this demo, we will be using just a plain text deployment. But we do highly recommend for future deployments to use our KMS encryption deployment type. So for more information on creating keys, you can also refer to this link that we've provided here. As well as later on in the running Terraform script section, there is a whole other section on encrypting secrets. Once again, we will be skipping over the encryption sections for this demo. With the GCP Setup section completed, we'll move on to the Cloud Access Manager. We can visit cam.terradici.com and sign in using a Google G Suite, Google Cloud Identity, or Microsoft Business account. So I have a tab opened here, and we can go ahead and sign into our account. Once we're signed in, you can see that we are in a default deployment. We will need to create a new deployment for Terraform to use. So under the menu, we'll create a new deployment. And once again, we'll enter a deployment name, and I will be calling it Cloud Deployment Scripts. We will need the PC over IP registration code. And once again, if you don't have one, please reach out to our sales team. So I will simply just copy and paste the code that I have. We will need to enter the cloud credentials that we've created in the previous section. So we'll select our key file and click enter. We will need to validate it before we can create this deployment. So once it's been validated, we can go ahead and click create. With the deployment created, now we can move on to create our deployment service account. So we can go ahead and click on deployment service account and click this icon to create a new key. So once again, we can just download the JSON file and click download and save it to our local machine. Perfect. Once that's downloaded, then we are good to go, and we can move on to the next section, which is running our Terraform scripts. So before we can move on to customizing our terraform.tfvars, which is basically just a configuration file for Terraform, we will need to download a copy of the Cloud Deployment Scripts repository to the Cloud Shell environment. So we can head back over to our repository homepage, and we can click on this button here, the green button code, and copy this so that we can git clone using this URL. With that copied, we can head back over to our Cloud Shell. So we can actually open the editor and then click on this button to open a new window. And this will give us our Cloud Shell down here, and also will initialize an editor that we can use up here. So we'll go ahead and clear this screen. And over here, then we can begin cloning the repository. So we can use the command git clone and copy in the URL that we copied. And once it's copied, we should see that as a separate directory up here. With our cloud deployment scripts now cloned into the Cloud Shell, we can finish setting up by uploading the two key files we have from earlier. One will be for GCP, while the other will be for CAM. In the top right corner, we can click on More and hit Upload File. We can enter both those key files at the same time and upload them. It should show up on the editor here, and you should be able to see each of those keys. Once that's done, we do need to finish setting up our SSH key pair. In the README file, we have a link to one of our pages for the SSH Key Pair Setup, so you can visit this page for more information. Under the SSH Key Pair on Linux Machine section, we have a command here that we can copy and use. So we'll go ahead and copy this. And heading back over to our Cloud Shell, we can paste this command in, which will ask us to save a key to a path. We can use the default value here. It would be useful to keep this value handy, as we will use this in the terraform.tfvars file. So we can go ahead and copy that. You can press enter and overwrite an existing file, because I have done this before, so this may not show up for you. And enter again for no password, enter again for no password. So once you see this, that means your key has been created in the path that you specified. We're now ready to move on to the next step, which is customizing terraform.tfvars. Terraform.tfvars is a file in which a user can specify variables for a deployment. It can be thought of as a configuration file for the deployment type you're working with. For each of the available deployments, there is a terraform.tfvars.sample reference file. Let's head back over to our cloud editor. In the editor, under our Cloud Deployment Scripts directory and under Deployments, we'll see that there's AWS as well as GCP. So we'll enter GCP, as that's what we're using today. And here are the 3 deployment types that were described in the architecture section earlier. As we'll be using single connector today, we'll go ahead and enter this directory. And here we will find the terraform.tfvars.sample file. As I like to keep this as a reference file, we'll actually go ahead and just duplicate this file, so that way we have a second file to use, which we can also rename as just terraform.tfvars. And this way, once we've finished customizing this file, it will be ready for use in Terraform. So there are just a couple notes here in regards to using the terraform.tfvars file. If we head back over to the README, we'll describe how uncommented lines show the required variables, and while commented lines will show the optional variables with their default or sample values. So we'll go through the terraform.tfvars file together, and we'll see that there are certain variables that are required, so we'll have to fill those out. And then some of the commented ones, such as the firewalls, as well as the SSL, some of these are optional, so we can just skip over these. And then the next thing is a complete list of also the variables are described in the vars.tf file. So we'll have a quick look at that as well. So for full customization under vars.tf, this is where you'll find actually all the variables associated with this deployment. So this is where you would change it. And this list is quite large. And finally, we just have a note here on the path variables used. As Linux and Windows systems use a different way of file paths, so because we are using Cloud Shell, which is a Linux environment, we can simply just use the path as follows. If you are on Windows, please check out the AWS video where we will be deploying it on a Windows machine, and so we'll need to use the Windows path and actually change the default backslashes to forward slashes. And once that's all done, once we're finished with filling out the TFVARs, then we'll actually just save as this file, which we've actually already done, and then it should be good to go. So back over in our Cloud Shell editor, we can begin going through our terraform.tfvars file and fill out all the required variables from top to bottom. The first one we'll be filling out is the GCP credentials file variable. This one we will require a path to the key file that we downloaded from earlier. So we can use the command ls to make sure we're in the right directory. And this is my key file name, so I'll copy that. And we can actually use a command called readlink-f, and we'll paste in the file name. This will return an absolute path to that file, which is what we need. So we'll copy this and paste it into here. When pasting in the values, be sure not to replace these double quotes, as they are required for Terraform. The next one is the project ID, and if we go back to our GCP console, we can find that by clicking on the project button here, and there should be a column for the ID for the project that you're in. So we'll paste this in as well. And just be careful with these spaces, and we can just remove them. And for the next one, it'll be the GCP service account email. We can once again find this in the GCP console. If we go back out to our service account page, you will see the email column. And we'll just copy this and once again paste it in for this value. So for the next few variables that we'll be going over, these are optional, and you can tell because these have the hash symbol, which is a commented out line. So to use these optional variables, what we can do is uncomment, delete the hash symbol, and this uncomments that line, and we can change the values here. And for example, if we want to use a region other than the default, which is US West 2, we would simply just change the values here and also uncomment it out. So I will be keeping this as the default values. For the next optional variable, this is the prefix. This is highly recommended as it reduces name collisions. What it does is it adds prefix to the resources. So I generally like to use my initials for this. The next two here, this is the allowed admin cider, and this one is the allowed client cider. By default, only the Terraform host is allowed to use ICMP, SSH, RDP, and WinRM. So if you want to allow additional IPs, you would uncomment this line and add the IP as well as the cider. So we'll be leaving this as a default value. This is mostly used for debugging purposes. For this next one here, this is for the PC over IP clients. By default, any IP will be allowed to connect. So if you want to add restrictions to which IPs and CIDRs are allowed to connect to these workstations, you would uncomment this line and once again just fill out the IP addresses. The next one here is the domain name. We'll just leave that as the default. And the next one here is the additional AD users to create. So we can add additional Active Directory users by using the domains users list file. So this CSV file is in the same directory as the terraform.tfvars file. And I like to keep the reference file as a sample, so we'll go ahead and do the same thing and duplicate this. And we'll just rename the file by deleting the copy and the sample. So we can add additional AD users by just putting them in this file. So we'll require the first name, last name, username, password, and a flag for if this is a admin user. So for example, we can do Edwin, Pal's last name, then we can do a username, a password, we'll just use secure password, and a flag is admin, so we can do true. And we can add more users simply just by adding another row. And this is false. So we'll save this file. And because we've renamed it, so it's already good to go. What we will need to do is actually cd into this file and get the file link once again, so that way we can have a full absolute path to that file. So we'll change directory in cloud deployment scripts, ls, and we'll change again into deployments. We'll enter the GCP, and we'll enter the single connector. So now we're in our directory, which is here. What we can do is we'll do the read link -f. And the path that we want is the domain users list.csv. And this will return a full absolute path, which then we can copy. And we can go back to our terraform.tfvars file and just paste in the path here. Once the path has been pasted in, don't forget to uncomment this line, as otherwise this will not be used in the deployment. So continuing down the list, we have other optional variables such as changing the image, the size, and the machine types. We will leave these with the default values. And the next one is an optional SSL key insert, and which we'll leave as default as well. And here is the admin SSH key that we created from earlier. If you didn't change the path of the key creation, then we can actually just use the default value. So we can make sure that we do have the correct key in this directory by doing a command ls and ~/.ssh. What this will do is return the files in this directory, and we can see that we do have the key created, id_rsa.pub, so this is good to go. And for the next few variables here, this is where we can set up our workstations. So the 4 types of workstations that we offer is the Windows Graphics, Windows Standard, CentOS Graphics, and CentOS Standard. So by default, these values are at 0. So we can create any numbers that you want. Just make sure you do have the appropriate quotas in your GCP project. So we'll go ahead and create just one Windows Standard. We can do a 1 Windows Graphics and 1 CentOS Standard. Right. So moving on, and this is the same thing. This is for the SSH key that we want to use for our CentOS machines. So we'll be using the same key as the connector. The last thing that we have to fill out is just all the secrets. So if we scroll down a little bit here, we will see Start of Secrets section. Before we jump into that, actually, this is where we would specify a KMS key. If we are using a KMS encrypted deployment, it will actually use this crypto key to encrypt all the secrets that are below this section, so that way they don't show up as plain text, and it is a more secure way to do these deployments. For the simplicity of this demo, I will just be using plain text, so I'll keep this commented out so that way it doesn't use the crypto key. So we'll finish off by just filling out our secrets. By default, we have just some placeholder values here. For this demo, I will just leave it as a default password, but definitely change these for better security. So I will just make these the same. And here is where we would paste in our PC over IP registration code once again. So I have mine here, and I will just paste it in. And the very last thing is a path to the Cloud Access Manager service account. So this is the other JSON key that we downloaded earlier in the video. So if we go back out to our main directory of where the key is, so once again, pressing ls, cd ... will move you back up one directory. So once we see the key that we're in the directory of the key that we want, we can once again use the same command, read link -f, and we'll paste in the file name, which is Cloud Access Manager Service Account. This will return the correct absolute path that we want to paste in. So we can copy this and paste this in. And with that, we are finished with setting up the configuration files, and we can go ahead and save this. We're now ready to make our Terraform deployment. If we head back over to the README page, you'll find that we are now finished with the customizing terraform.tfvars section. In the next section, this is an optional section for KMS encryption. There are 2 methods, and if you are interested in using KMS encryption for future deployments, perhaps, please refer to the section, as there are 2 ways of doing it. The easiest way would be to use a Python script that we've provided. The Python script will take your TFVARS file as an input and actually will rewrite the file and encrypt all the secrets for you. So this is highly recommended. Or if you prefer to do it manually, we also have all the commands you need here as well. Now, moving on to creating the deployment. This is perhaps the simplest part, as there are just only 2 commands that we need to use. So now with it customized, we'll use the terraform init command. So we will have to go back to our directory in the single connector. So we'll first clear the screen, and we'll cd into Cloud Deployment Scripts, and we'll cd into Deployments, and we'll cd into GCP, and then single connector. Once we're back inside our directory, we can use the command terraform init. This will initialize all the modules and install all the required provider plugins for you. Once you see this message, Terraform has been successfully initialized, we can then use the second command, which is terraform apply. This is what will actually begin our deployment. One thing we can do to make sure that our terraform.tfvars is filled out correctly, without committing to a deployment, we can actually use the command terraform plan. So this will catch any syntax mistakes or any errors that may come up before we actually make the deployment. And since we didn't see any error messages, that means our terraform apply should be good to go. So we'll go ahead and do terraform apply. And we'll enter yes to continue. The deployment will usually take about 20 to 30 minutes. And when it's complete, you should see output that's in green text. So we'll let this run and we'll come back once it's finished. Once the Terraform deployment is complete, a green output message should appear on your console. This message will contain useful information such as the internal and public IP addresses for the VMs we've just created. Here's the internal and public IP of the connector, and just below it we'll find the internal IPs for the 2 workstations that we've created with Terraform. By default, the public IPs for these workstations are disabled, as this way the workstations are not directly exposed on the public internet. In the vars.tf file, there's a variable named enable public workstation halfway down the file. This option is false by default and can be changed to true. Next, we'll head back into Cloud Access Manager. We should first make sure we're in the correct deployment. Should be Cloud Deployment Scripts. And then we can click on Connectors. We should see the single connector that we've created show up. And the health may sometimes come up as unhealthy because the state's not immediately synced up to CAM. If we wait a little longer, it should appear healthy. We can also see the IP addresses of the connector we've just created, and this should match up with the IP addresses on the console. Back over in CAM, we're now ready to add remote workstations. If we click on Workstations page, we can click on the Add icon, and we'll have 2 options. The first one will be to add an existing remote workstation, and the second is to create a new remote workstation. We'll go ahead and click the first option here. And for provider, we'll select GCP. For the zone, we'll select US West 2B, which is what we made our deployment in. We can go back to our terraform.tfvars file just to make sure we have the correct zone. Under GCP region and zone, we'll see that it is indeed US West 2B that we made our deployment in. So that's what we'll select. For the next option, this is where we can choose the remote workstations that we're adding. And the first one is a standard CentOS, and the second is a graphics Windows. For the user entitlement, this is where we can add user accounts that we want access to these workstations. You can see the default is the CAM admin, so we'll go ahead and add that, as well as the users that we've created using the userslist.csv file. So we'll add all 3 here, and we'll click Save. If we hit the refresh button, these workstations should now show up, and the power status should also be showing running. With the 2 Terraform provisioned workstations now added to CAM, we can now try creating and adding a new remote workstation using the CAM user interface here. Under the Workstations page, we can click on the plus icon once again, and we'll select Create New Remote Workstation. Once we're inside, we can choose a provisioning template. We offer both the graphics and the standard agent for CentOS as well as for Windows. So let's try creating a second standard CentOS machine. We'll need to specify a machine name, which will use the same naming structure with a prefix. We'll next need to select a region. We'll select our region, which is US West 2, and the zone US West 2B. For the network, we'll select the one that we've provisioned using Terraform, which is VPC CAS, and we'll select the subnetwork, which is subnet-ws. Here we have an option to add a public IP. We can actually disable this as our workstations are configured with a NAT gateway, so they do have access to the public internet. For the machine type, we'll select something like a 4 GB and 4 virtual CPUs. For the disk type, we can select standard persistent. We'll give it a size of 64 GB. For the Active Directory information, we'll need to make sure we're adding the correct domain name here. If we go back to our terraform.tfvars file, near the top of the file, we'll find the field for the domain name, which we'll just double check and make sure we didn't change it. So we've left it as the default, which is example.com. So that's what we'll enter here. And for the domain service account, we'll be using the default one, which is cam_admin. And to find the password for the service account, we'll go back to our terraform.tfvars file. And in the secrets section, it'll be for the AD service account password. So it's whatever this value you've set in your TFVars file. So I'll be entering my password. And once I'm done, I'll click on Create. This process may take up to 10 minutes, and you can see that the power status that it is creating. So we'll come back once this is complete. So while that machine is provisioning, we can head into the GCP console here, and under Navigation menu, Compute Engine and VM Instances, we can actually see a list of all the provisioned VMs. Here you'll see our graphics windows, our standard CentOS machines. Standard CentOS 01 is the one that we've actually just created using CAM, and we can also see our connector as well as the domain controller. If we head back over into CAM, what we can also do is just add the user entitlement for the machine we've just provisioned. So that was scent 01. So if we click on this, we can here select the users that we want access to this VM. So once again, we can add the default account for the administrator, which is cam admin. We'll add our users, Edwin and John. And we can go ahead and click on Add and Save. So once that's updated, we can go back into the Workstations page, and we can see that the machine is updating now and should be going into the running status soon. So once that's ready to go, we can now use a PC over IP client to test and connect to our workstations. And while it's still updating, we'll actually go ahead and get our next section ready, which is starting the PC over IP session. So in order to do this, we'll need to download the client. If we head over to the Teradici page, teradici.com, under Products and under PC over IP Clients, if we scroll down, you'll see a link to the software clients and mobile clients. Hit View Downloads, and download a client for Windows, Mac OS, or Linux, as well as mobile clients. For additional help, there's an administrator's guide as well that you can check out for each of these. I already have mine installed, so I'll just go ahead and get it started up. With the standard CentOS that we've provisioned using CAM now up and running, we're now ready to test our Terraform deployment using the PC over IP client. If we head over to our connectors page, we'll need to copy the value for the external IP of our connector. I already have my client up and running, so we'll just go ahead and paste in our IP address here into the host address and click on Next. We may get a message that pops up saying that this is insecure, and that's because we didn't use the SSL certificate option in our terraform.tfvars. So for now, we'll just go ahead and click on Connect Insecurely. Here we'll need to give it a username and password. The default admin account will be cam_admin. And once again, the password will be the one that's set out by you in the service account password field in the secret section of your terraform.tfvars file. So I'll go ahead and enter mine. Click on Login. Once we're logged in, you'll see that these are the remote workstations that we've given ourselves access to using CAM. We'll see that we have the standard CentOS, the graphics windows, as well as the standard CentOS that we've provisioned using CAM. So let's test out our graphics windows first. So we can go ahead and click on Connect. And after a couple of seconds, we should load into our Windows desktop. We can resize the desktop by simply dragging out the window here, and the desktop should resize as well. We'll finish off by testing the other workstation that we've provisioned using CAM. So we'll need to use the same IP address here to log in once again. We'll click on Next. And this time we'll use a different user. If we go back to our Cloud Shell and open up our user list.csv file, we'll see that we have our two other users that we've created. So let's give this username a try with the password that we've specified here. So if we go back into our client and we'll type in our username as well as the password. And we'll see that we should be able to log in with that credential. We'll see that we've added the 3 workstations for this user, and that's why we see both standard CentOS as well as the graphics windows. Let's test out the standard CentOS that we've provisioned using CAM. So we'll click Connect. After a short couple seconds, we should get in as well, and we can resize the window just like for Windows. So one thing to note is that while these machines are not accessible directly from the public internet, since they are inside a private subnet, but they do have internet access via a NAT gateway that we've configured that Terraform deployed. So we can test our internet connection by just opening up Firefox. And we can visit a website such as terradg.com. And you'll see that we should have internet access. Feel free to pause the video here if you'd like to explore the remote workstations further. You can also click on the Maximize Window button here to full size the PC over IP client. This way you can experience the high definition and highly responsive remote workstation firsthand. We can now move on to the last 2 sections, which are changing the deployment and deleting the deployment. Terraform is a declarative language used to describe the desired state of cloud resources. What we can do is actually modify our terraform.tfvars file and run terraform apply again. For example, we can use this to add or delete remote workstations. And what Terraform will do is try to apply these changes to achieve the new state. If we head back over to our Cloud Shell, for example, in our terraform.tfvars, we can remove our graphics windows by changing the 1 to a 0. And we can use the same command used for deployment, which is terraform apply. And we'll confirm by typing yes here. And you'll see that Terraform here wants to destroy 2 resources associated with the change that we've made in the terraform.tfvars file. So we'll type in yes and enter. And this apply will be shorter than the first one we did. However, it may still take a couple minutes. With Terraform apply complete, we can head into the GCP console to confirm. We can indeed see that our Windows graphics workstation has been removed from this VM instances list. When we remove workstations using Terraform scripts, CAM doesn't know about this, so for a proper cleanup, there are 2 things that we have to do. First, we have to remove it manually from CAM, so if we go into our CAM dashboard again, and under Workstations, we'll have to manually remove this entry. So we'll click on this, and Actions, and we can click Delete. Since it's already been deleted from GCP, we can simply just hit Confirm. And the second cleanup item we'll have to do is to remove the computer object from the Windows DC. Our Terraform scripts take care of joining the domain, but they don't unjoin the domain on deletion. Before we can run the Terraform Destroy command to tear down our deployment, if we've created any remote workstations using CAM, we also have to delete these workstations using CAM, as Terraform would not know about them. If we head over into CAM and under Workstations, we have our standard CentOS 01 that we've provisioned using CAM. So we'll need to check on this and also click on Delete. We'll also use CAM to delete the workstation from GCP, as once again, Terraform will not be able to do this. So once that's been deleted, we can also just confirm that this machine is being brought down on GCP console as well. So we can just simply refresh it. And we should also see the state here being destroyed. And then the final section, we can just refer back to our README file here. It's to run Terraform Destroy. So this is a very simple command that we can go back into our Cloud Shell, and we'll just type Terraform Destroy. And once again, it'll probably prompt us here, and we'll have to enter yes. So this time you can see that since we're destroying the rest of the infrastructure, there are 31 resources to destroy, and we'll confirm by typing yes and enter. The destroy process should take roughly about 5 minutes, so we'll come back once it's complete. With Terraform Destroy completed, we can head back over to our GCP console to make sure all resources have been removed. Great, it looks like they have. The last section here covers troubleshooting. If you encounter any issues, you can head over to our troubleshooting page for more instructions on how to debug your virtual machines. We include instructions on how to connect to these workstations using SSH for CentOS and RDP for Windows. And here we'll find also the log locations for some of the important system logs, as well as the provisioning logs. If you encounter any bugs or any security issues, please reach out to Sherman Yin, who is the maintainer of this repo. This concludes our demo video, and thank you for watching.